This video lecture is meant to cover the information found in Unit 10, Chapter 11, and the topic is classifying reaction types. This covers objective number 5, which says to identify and classify chemical reactions as either combustion, combination, also called synthesis, decomposition, single replacement, which is also called single displacement, or double replacement, which is also known as double displacement. You should have a handout that has 5 separate arrows with 4 equations written in them, and we are going to look at each group of 4 reactions and decide what they have in common. The first arrow has 4 equations in them, and if you might notice the similarities here is that they all contain oxygen as a reactant. They all have carbon dioxide and water as the only products. The reactant at the very beginning are what we call hydrocarbons. These are compounds containing carbon and hydrogen. Sometimes they contain oxygen, but they are called hydrocarbons because they contain carbon and hydrogen for sure. Now, this is what we call combustion reactions. Combustion means to burn, right? And so these are all hydrocarbons that are burning, which means, you know, they have to combine with oxygen, so hence there has to be oxygen as a reactant. So combustion is a hydrocarbon that burns and produces carbon dioxide and water as products. So those are the things to look for when noticing a combustion reaction. You will have some hydrocarbons, some X number of carbons and Y number of hydrogens is a reactant. O2 is a reactant. And CO2 and water are the products. Here is a little video that is going to show you the combustion of methane and oxygen forming carbon dioxide and water.
A combustion reaction occurs when a substance rapidly combines with oxygen to form one or more oxides and releases energy.
So let's go ahead and take a look.
There are
at
5 major classes of chemical reactions.
Batch of reactions here. And what do we notice about this second batch of reactions? We see 2 reactants here and here, 1 product. 2 reactants, 1 product. 2 reactants, 1 product. 2 reactants, 1 product. So this is known as a synthesis reaction. Some textbooks will refer to this as combination, but I tend to refer to it as synthesis reactions. And so what you're looking for here is you are looking for 2 or more reactants turning into 1 product. So that's the key. You can have 2 or 3 or 4 reactants, but it will always turn into 1 product. All right, let's go ahead and I'm going to take a look at a video that corresponds to this. Okay, so here's a little animation that'll show you the synthesis. Here we have hydrogen and chlorine synthesizing to make 1 new compound, HCl.
A synthesis reaction is when 2 or more substances combine to form a single product.
So here we see this is the HCl and this is HCl, and so it looks like, you know, we're only supposed to have 1 product, but you see 2 molecules here. And so the idea is, yes, you can have more than 1 molecule, but if you'll notice, these molecules are identical. They are both HCl. So that's what we mean when we say it produces 1 product, 1 type of molecule.
A synthesis reaction is when 2 or more substances combine to form a single product.
right, let's take a look at the next type of chemical reactions. And here what you should notice is that there is one reactant but two products. This is what we call a decomposition reaction. And the key thing to look for here is one reactant turning into two or more products. But the key is you can have 2, 3, 4 or more products, but the idea is you are starting with one reactant. So let's take a look at this video, which is going to now show us a decomposition reaction.
In a decomposition reaction, a compound breaks down into two or more simpler substances.
Okay, so there you can see we started with one type of molecule and we are now ending up with two different kinds of molecules. All right, the fourth kind of reaction we see here, what we notice is that in each one of these equations we have an element and a compound on the reactant side. Element, compound, element, compound, element,
In a
compound.
decomposition reaction,
On the
a
product
compound
side, we
breaks
have
down into two
also
or more
element
simpler
and
substances.
compound. But what we see now is that the element is not the same element that we started with. Here we have silver as the element on the product side. We started with copper as the element on the reactant side, and what has happened is the copper has taken the place of the silver in the silver nitrate. So the key thing to look for, element, compound, element, compound, element, compound, compound, element. Right? So the idea is that this is what we call a single replacement, also known as a single displacement. But what you are looking for to recognize this kind of reaction is you'll have an element plus a compound turning into a different element plus a different compound. In this next video on single displacement or single replacement, you will see that we have iron reacting with copper sulfate. And what will happen is the iron and the copper will switch places.
A single displacement reaction is when one element takes the place of another in a compound.
Our final reaction type here is similar to the single replacement, but now what will happen is you will start with two compounds. We have a compound and a compound forming a compound and a compound. Compound, 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 compound. So what happens here is the cations will switch places.
A single
So here,
displacement reaction is when
for
one
example,
element takes the
the
place of
iron
another in a
will trade
compound.
places with the hydrogen, so that you will have H going with the S over here, and you'll have the iron and the chlorine going together over here. So this is what we call a double replacement. And what you are looking for to recognize this is compound plus compound turns into a different compound plus a different compound. So the most easily confused reaction with a double replacement is a combustion reaction, but a combustion reaction is very easily recognized by the fact that oxygen has to be a reactant and carbon dioxide and water have to be products. So double replacement, really the key thing is that the cations switch places, and that's what you're looking for. All right, so let's just wrap up this lecture with the final video showing the double replacement reaction. Here we have AgNO3 silver nitrate reacting with potassium chloride, and what will happen is the Ag and the K will switch places so that we end up with AgCl and KNO3. right, well there you have it. That finishes up this video lecture on classifying chemical reactions. We'll see you in the classroom.